Welcome to 22.1, which I've entitled Current Electricity. We're going to be talking about some very basic electrical terms. Terms like current, voltage, and power. You've probably heard all of these things before. You know, I've got a 12-volt car battery, or I plug something into the wall, it's 120 volts, or 240 volts, or I've got this many amps, I've got this many watts. These are volts, amps, watts. They're all, how do you know the difference between them? My goal by the end of this section, you'll know the difference between amps, volts, and watts. And what do they physically mean? You know, if I told you you have 6 amps, what does that actually mean? Or you've got a 9-volt battery. What does 9 volts physically mean in the electrical world? So let's get started. The first thing I want to talk to you about is where do we get our voltage from? And we get our voltage from and our current from batteries. The first thing is current, and that's the flow of charged particles. When you have an electron going from point A to point B, we call that current. A cell is something that takes chemical energy and it converts it into electrical energy. And there's all different types of cells. Like they have lithium ion, there's nickel metal hydride, there's all sorts of different polymer batteries, but they're all lumped into what's called a voltaic cell. When you take something like this, like the classic AA battery, we call that a voltaic cell. There's something called a photovoltaic. Now that takes sunlight and makes it into voltage. And then another type we call a battery. A lot of times you refer to this thing right here as a battery, but really it's just a cell. There are batteries like a 9-volt battery. If you were to take a 9-volt battery apart, there's actually 6 different little cells inside there. So that one's actually truly a battery. And you know, your car battery, there's different divisions of containers inside of this battery, which makes it a true battery. A battery meaning more than one cell. So just some commonplace terms. When we get talking about electrical things, we have what are called circuits. Now, a circuit is a closed loop of current that there's this beginning and end. If you start here at the positive terminal of our battery, follow this wire, and it goes through a motor, it comes out of the motor, and it goes through this thing called a potentiometer. And a potentiometer is what's called a variable resistor. You don't have to know any of that yet. And then it goes through a switch and then back to the battery. So you have this closed loop. Now, every circuit needs 3 different things. The first thing it needs is some source. You have to have something that supplies electricity to the whole. Something's going to be supplying it, and in this case, it's a battery. We can have all sorts of different sources that you'll see. The next thing you need is a pathway. You need something that is an electrical conductor that can allow electrons to pass through it to complete that circuit. And the last thing is, and this is the kind of tricky one, it's called a load. You need if you just were to hook up a battery, the positive to a negative on a battery, you have lots of current flowing and that generates lots of heat. And we actually call that a short circuit. You're short one of the 3 things. You're short the load and you get sparks, you get heat, and you get things burning, and that's not good. So you have to have a load in every single circuit. Otherwise, you get an overload of current. And in this case, it's the motor and the potentiometer. Now, we're going to get into some terms, but before I get into these terms, I wanted to show you this video by our friend he's Veritasium. He has his PhD in educational media, and this was back in 2008. So he's since gotten a lot better with his presentations, but he does a really good job of explaining all these electrical terms, and he's got some really interesting animations that I think do a better job than I can right now. So let's give him a listen.
In this segment, I'm going to deal with the basics of electricity. I think it's easiest to think of electricity in analogy to a river or a creek. A fundamental quantity in a river is how much current is flowing. In other words, how much water is passing a point in a second. With electricity, current is also really important. But now we're talking about charge that passes a point in a second, not water. We measure that charge passing a point in a second in coulombs. So the current, which is given the symbol I, should be measured in the number of coulombs that pass a point in a second. Just like in the river, we might measure the amount of water that's flowing past a point in the number of buckets of water that are passing a point in a second, say 15 buckets a second. In a wire, we'll count the number of coulombs that go past a point, and that is the value of current, say 3 coulombs per second. A coulomb per second is given a special name. That name is an amp. But you must never forget that what an amp means is it means a coulomb passing a point in a second. So if there's a current of 5 amps flowing, that means 5 coulombs are passing a point in 1 second. Current is the easy part of electricity because I think it's not too difficult to think of the number of coulombs that are passing a point in a second. Voltage is a little bit trickier. Voltage or potential difference. I think the best way to think about that is to think about a lake. If we had a lake, there would be no current flowing. Why is that? The reason is because the bottom of the lake is flat. If you were to pick up one side of the lake and lift it up a little bit, then the water would start flowing down towards the other side. What you've done is you've created a difference in potential, gravitational potential energy. The side that you've lifted up now has more gravitational potential energy than the other side. So the water will rush down from higher potential to lower potential.
See, and I like to refer to voltage as pressure. So he thinks of it as a gravitational potential, like you lift it up and then it starts flowing. The higher you lift it up, the more voltage you give, and I like to think of it as pressure. Voltage is how hard the water is being pushed. If you don't push it, you don't get any electricity flowing. If you push it really hard, you can get lots of electricity flowing. Depending upon your wire, if there's resistance or a kink in the hose, which we'll get to in 22.2.
In electricity, it's a very similar thing. The way we make current flow is we produce a potential difference in the wire. Not a gravitational potential difference, though, this time, an electrical potential difference. The way we can do that is with a battery. With a battery, that's like picking up one side of the wire and putting it at a higher electrical potential than the other side of the wire, the other end. So electrons will tend to flow from the higher potential down to the lower potential. And the greater potential we apply, the more the electrons will flow, the greater the current will get. In a very similar way to the river. The greater the difference in height in the river, the more the current will flow. So why do we use the word potential? What does that mean? The word potential refers to the potential to do work. The potential to do work is given in units of joules per coulomb. That is the energy per unit charge. But 1 joule per coulomb is given another name. It's called a volt. But you must remember, if someone tells you that there is a potential difference across a wire of 10 volts, that means that 1 coulomb of charge at the higher potential end can do 10 joules of work on its way down to the lower potential end.
And we've seen joules before. In thermodynamics, we talked about how much energy it takes to, we turn that into heat. We've also seen it when we did our simple machines, like how much work, force times distance, that's in joules. So you're starting to see the connection between like electricity and physically moving objects and creating heat. They're all using joules, which is energy.
Or it can do 10 joules of work more than the charge, 1 coulomb of charge, at the lower potential end. So let's think about this as an example with a 1.5 volt AA battery, a standard battery. What does that mean that it's a 1.5 volt battery? Well, it means that if 1 coulomb of charge came out of one side, it could do 1.5 joules of work before re-entering the other side of the battery. So if you connected the battery up to a little light bulb, each coulomb that came out of the top of the battery and went through the light bulb would give off 1.5 joules of light and heat before it re-entered the other side. So, to summarize, there are 2 fundamental quantities in electricity.
Yeah, we'll skip the summary. I'll summarize it for you here. First of all is a coulomb. A coulomb, you see it as the letter C, and it's the letter Q in an equation. When he was talking about coulombs, he said every coulomb that goes by in 1 second, that's an insanely large amount of electrons. He omits that, but if you wanted to actually figure out what 1 amp is, 1 amp is this many 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Whoo! There are this many electrons flowing per second, and that equals an amp, and that's just an insanely large amount. And you're asking yourself, why is it so big? We defined the amp before we understood what an electron was, and it turned out that electrons are so small that it just was really bad. So there's tons and tons and tons of electrons in 1 amp. And you do the inverse of that. So if there's this many electrons in a coulomb, then how many coulombs are there in an electron? The amp, 1 coulomb per second, we talked about. The voltage, and he said also, it's important to note that the volt is equal to 1 joule per coulomb. That every coulomb that comes out of the battery or the cell can, if it's a 1 volt, it can do 1 joule of work when it returns to the other side. Now, the units for amps are amp, and the units, you'll see it as the letter I in an equation. And voltage, the units are V, volts, C's in equations, V. And we talked about water. And I like to use pressure. Like if I push on the water, I have voltage. So you could have a really low voltage, low pressure, and low current with low amount drop of water. You could have low voltage but high current. So a lot of water flowing but not being pushed very hard. You could have high voltage, it's pushing really hard but there's not a lot of current there, like a hose. Or you can push it really hard and have a high amount, and you talk like raging rapids, fire hose sort of thing. And we'll talk about this, but it's the current. The current is what is dangerous to people. High voltage doesn't necessarily mean that it can hurt you. It depends on a lot of things. So we'll get to that in part 2. But here's another unit that we're going to learn, and that's power. Power is current times voltage, and power, the units of power are watts. So here's a quick example problem where it says a 6-volt battery delivers this. What's the power? Power is the current times the voltage. So our current is 0.5. Our voltage is 6. So half of 6 is 3. And that's watts. There's a 3-watt motor. If the motor runs for 5 minutes, 3.0 watts is 3.0 joules per second. That's what a watt is. And we run this thing for 5 minutes, which is 5 minutes is 5 times 60 or 300, and you take 300 times 3, that's 900 joules that we're going through with significant figures. We got a whole bunch of different example problems too around the corner here. We'll look at those. Not really. I mean, they're all just applications of this P equals IV. These questions are pretty straightforward. I mean, a couple more just to kind of get you interested and to show you, like, how many electrons does it take to produce 50 coulombs of charge? You know, and you have 50 coulombs, and 1 coulomb is equal to, if you remember, I think it was 6.18 times 6.25 times 10 to the 18th. There's tons and tons and tons. I don't even think your head can wrap around this. You have 1 mole of electrons, 6.022 times 10 to the 25th. How does that work? But this is just an intro. What is an amp? What is a volt? Pressure, an amount, an electron. These are all very simple things that we're talking about in terms of electricity.